Good morning to all. So today we'll continue chapter 12, that is ANOVA analysis of variance. We have already studied that when we have to compare the two means, then we go for t-test, and when we have to compare more than two means, then we use this ANOVA technique. In the last class, we have discussed one-way ANOVA technique. What was one-way ANOVA technique? When we have got one factor, that is, suppose the question shown here is different 4 types of fabrics are there. So we are comparing one factor, that is fabric type, and 4 types of fabrics are there, and we have got the readings of abrasion resistance and we have to compare that the readings which we are mean readings which we are getting for these 4 fabrics, is there any significant difference between these 4 fabrics? Okay, the process we discussed in the last class was, first we have to calculate the sum of the squares of all individual observations, then we calculate the sum of squares for fabric and sum of squares for grand total. And then we have to make this ANOVA table in which we get this between fabric type variation and within fabric type variation. What is the meaning of these terms? I have already shared a link of video also for this better understanding. You may go through that also. But basic thing which we need to understand here is, we are given 4 populations and we are studying the variation within the data and variation between the data. If the variation between the groups is higher than variation within the groups, then only we can say the 2 data are coming from the different population. So that is the basic concept. We compare the variation between the fabric types to the variation within the fabric type, and getting the information that all the 4 fabrics or all the 4 datas are coming from different population, or they are coming from same population. So we get the answer in the form of yes or no at a given confidence level. For example, in this question, we get the answer yes, there is a significant difference between the means of the 4 fabric samples at 5% confidence level. Now what is the meaning of this yes? There is a significant difference. Now the difference is between which 2 samples, if we need to identify. Suppose out of these 4, first and second sample has significant difference, and second and third doesn't have, or third and fourth doesn't have. So if we need to identify which 2 fabric samples have significant difference between them, we have to extend the process to finding least significant difference. There are 2 ways in which we can proceed. First is if there is a control reading is given, or a reference reading is given, and all other readings you have to compare with that control or reference specimen, then we go with the first procedure, and in the second procedure we just calculate least significant difference and compare all the differences between means with that particular LSD value. Okay, so we'll discuss one by one these 2 things. First is comparison with the control. You just have to remember these formulas and try to find the LSD value. So here when we have to compare with the control, I have found this value Tk alpha S upon root n, and I found this value to be 1.6075, and for 95% confidence level, I have seen the T table and got this value 2.31. Now LSD, that is least significant difference, I have got this value 3.032. So this is the least significant difference. Now you will compare the difference between the means. If the difference between the means of the fabric samples is greater than this, then the difference is significant, and if that is less than this, then the means is not significant. Now I have shown it here. And second option is two-case procedure. In the two-case procedure, we just calculate this value QCKS 1 upon 2, 1 upon NH plus 1 upon NI, where H and I are treatment numbers being compared. Suppose different number of readings are there in two fabrics. Now in this present question, this is same for all, and this QCK is basically studentized range. Different table is given at the end of the book, table A6. You will have to refer that. Okay, now I have shown the calculations here, and we find the least significant difference by the second method, that is two-case procedure. It is 4.204. Now what we'll do is, we'll just calculate the difference between all the fabric means. Now suppose these are the fabric means, fabric 1, 2, 3, 4, and these are the differences between 1 and 2, 1 and 3, 2 and 3, and all combinations are shown here, and all the differences are shown here. So it can be easily seen that the difference between 1 and 2 is 1, 3 and 4 is 0. So which is lower than this least significant difference. So there is no significant difference between the mean for 1 and 2 and 3 and 4. But the difference between 1 and 3, the difference between 1, 3, 1, 4, 2, 3 and 2, 4 is greater than the least significant difference. So answer is yes. Now we'll continue to the second question of the exercise. That is also about one-way ANOVA. So you need to do that in assignment. And today I'll give you an introduction about two-way ANOVA. So we'll move to question number 3 here. You can do the questions in examples also to practice them. Okay. Now this is question number 3, and this is about two-way ANOVA. We need to understand this today. Why this is about, what is the meaning of two-way ANOVA and one-way ANOVA? In one-way ANOVA, there was only one factor, which was fabric type. We were studying the effect of fabric type on abrasion resistance. Now this is question number 3, and as we can see, there are two factors. One is fabric type and one is process type. So basically they are studying the effect of 4 types of fabrics, that is worsted, Barenthia, twill and Melton, and also they are studying the effect of process type, which is hydro, suction and mangle, and they are studying the effect of these two factors on percentage moisture content remaining in the fabric. So whatever property we are just studying, but the main thing we need to understand is, in case of two-way ANOVA, procedure is similar, but we'll get 2 F ratios, 1 F ratio for fabric and 1 F ratio for process, and we'll compare these two values with table values, and answer will be either yes for fabric or yes for process, or no for fabric or no for process. Whatever, we'll get 2 individual yes or no for fabric and process type. So I'll continue here. I am given the 4 into 3, 12 readings are given. So first step, you need to these row additions you have to find, and these column sums also you have to find, and this is the grand total. First step, you just find out these values. Okay, now earlier also we just sum of squares of the all individual readings, we call it S1, and here S process and S fabric also we have to calculate. S process, because there are 3 processes, so hydro, all the readings in that column we need to add and square them and then add. So hydro readings we get 170 square plus 276 square plus 238 square. Now this one reading is coming after adding 4 readings. We can see in the question there. this one reading 170 is coming after adding these 4 readings. So we need to divide by 4. So we get S process this value. Please calculate and match your readings. Now this is S fabric. Now there are 4 types of fabric. So first sum total is about worsted. So this 156 I am getting after adding these 3 readings. So we'll divide by 3 in case of fabric, S fabric. And S grand total we have already done. That grand total whole square divided by total number of readings was 12. So we just get these 4 values and then we'll make the ANOVA table. Now in this ANOVA table, this is source that is between fabrics and between process, and this is the residual error, and this is total. First always calculate total by subtracting S grand total from S1. This value will always be the highest, which is total value. Now when we are calculating between fabrics, then we have to subtract S grand total from S fabric, and for process we have to subtract S grand total from S process. So we'll get these 2 values 498 and 1442. Now for residual, please subtract these 2 values from the total and you will get this residual error value. Now degree of freedom, because there were 4 fabrics, so n-1 will be 3. There were 3 processes, so n-1 will be 2, and totally 12 readings were there, so n-1 will be 11. Now 11 minus 3 minus 2 will give you 6, which is the degree of freedom reading for this residual error. Now we have to calculate mean squares, which is sum of squares divided by degree of freedom. So you will get these 3 values 166, 721 and 67.67. Now we have to calculate F ratio. Now this is the F ratio for fabric and this is the F ratio for process. Now for fabric, we'll take the mean square of fabric divide by mean square of residual error, and this is mean square of process divide by mean square of residual error. So I have got these 2 calculated values. 2.45 is for fabric and 10.65 is for process. Now when we see the F table, for the table values we need 2 things, K1 and K2, except after deciding alpha, which will be 95% only. So K1 and K2, this is K1 for fabric and K2 for fabric, 3 and 6. When we'll be seeing table value for process, then we'll take K1 as 2. This is K1 for process and this is K2 for process. K2 will be same for both, but K1 will be different as there are number of fabrics and number of processes are different. Now table value of F is 4.8 and calculated value is less for fabrics. So for effect of fabric type, there is no significant difference between the different fabric values. And for effect of process type, answer is yes, that there is a significant difference of the process type on the moisture regain values. So this way we have to calculate the 2 F values and compare them with the table values, and there will be 2 answers in two-way ANOVA. So thank you. We'll continue in the next class.